We are looking at lesson 6.2 today, which is exponential models. Basically, looking at our basic exponential equations. Remember last week we talked about y equals a times b to the x. So looking at those basic equations in different scenarios. The first scenario, and what we're going to spend a lot of time on, is interest, okay, the compound interest, because compound interest is an exponential formula. Okay, so we're going to work with compound interest, and then eventually we'll talk about how to write an exponential model on the back. But it's really working with a lot of money. Okay, so compound interest formula, an exponential model that is used to calculate the value of an investment when interest is compounded. For instance, when interest is paid monthly, the interest earned after the first month becomes a part of the new principal for the second month, and so on. Interest is earned on interest already earned. Okay, so the idea when we talk about compounding is, okay, how often do they recalculate your account? Okay, and if they're recalculating it every month, well, then that means any interest you earned last month is now part of your new balance. And so now you have a bigger balance to earn interest on, so on and so forth. Okay. The formula we're looking at here is familiar in that it looks like interest, right? Or it looks like our exponential formula from last week. A equals P times 1 plus R over N raised to the NT. Now, if you guys remember anything about what you've done with interest before, P stands for the principal. It's your initial amount invested. Okay, so P is your amount of money that you start with. R, just like last week, it's our annual interest rate, and of course written as a decimal. N is your number of compounding periods per year. Are you compounding monthly? Are you compounding quarterly? Are you compounding annually, semi-annually? Okay, and we'll talk about that. And then A is what my equation equals, and it's just the total value of the account after T years. So T, of course, standing for years. Okay? So there's your formula. You're going to want to be familiar with, because we're going to use it over and over and over and over again. Okay? So let's go to example A. You have the formula. I have my example A on my next screen. Let's look how to use the formula. Tamara invests $5,000 in an account that pays 4% annual interest. How much will there be in the account after 3 years if the interest is compounded annually, semi-annually, quarterly, or monthly? Okay, guys. Let's go through, first of all, and identify. What did they tell us? What information did they give us? Okay, what she invests, $5,000. Where's that going to go in to the equation? That is your P. That is your principal. Okay, what else do they tell us? Okay, they say 4% annual interest. So when we put 4% in for R, what is 4% as a decimal? 0.4. Not 0.4. 0.04, because you've got to move that decimal 2 places, right? Or divide by 100. Okay, and what else do they share? Okay, how much will be in the account after 3 years? What is this 3? That is your T. Okay, now, the other thing is they're now asking 4 different questions. I don't know if you guys caught that or not. But the first thing they're going to ask about is annually. So let's set up annually. If interest is compounded annually, how many times a year is it compounded? Okay, if something happens annually, it happens once a year. So that means that N is going to be 1 in this scenario. Okay, that's what's going to be changing every time. So let's use our formula from above. A equals P. What is P? 5,000 times 1 plus R over N. 0.04 divided by, what's n this case? 1. Raised to the nt. So n times t. N is 1 and t is 3. Okay, there's your equation. Now, I like to clean this up a little bit before I put it into my calculator. In that, I like to clean up the parentheses and the exponent. So this is 5,000. Now, the 1 makes this one easy. What is 0.04 divided by 1? 0.04 plus 1. This is going to be 1.04 raised to the power of, what's 1 times 3? 3. And now we grab the calculators. Because from here, it is purely a calculator finish. My recommendation, if I'm using my calculator here, I have the one up that you guys have, I would just plug this in all as 1. Okay, that would be my recommendation. If you're not a plug it in all as 1, here's what I'm going to say, is you have to do the 1.04 to the third and times the 5,000 is your option. Okay, it's not 5,000 times 1.04 and then raised to the third. Now, as I said, what I would do, 5,000, you see what I'm typing, times 1.04. I don't even have to have the parentheses because it's already one number. Do we know our exponent button?
Yeah.
It is that little arrow button here. Okay, so that arrow is my exponent button, raised to the third. And I know some of you are like, oh my gosh, Miss Starch, I know how to use my calculator. That's fine, not everyone does. Okay? So sorry if I'm being too basic. Some of us need the basic. Does your screen match my screen? Okay? If so, success, right?
So you can't put it in just like that. Like, can you still do that parentheses and the raise to the third?
Yeah.
That's what I did,
Yeah, so like, in other words, 5,000, did you do times or did you go straight to parentheses?
I just went straight to parentheses.
Okay, so 1.04 parentheses raised to the third like that?
Mm-hmm.
Yep, that works too. Okay. And here's the deal, you find what works for you, right? What's your brain going to remember how to do best, and how's your calculator work with you? Some of your calculators are a little bit different. I'm assuming you're figuring it out. Ask me for help if you didn't get the same answer, okay? Because I need you to know how to use your calculator. How are we going to give this answer? This answer is in terms of what kind of label? Money, right? How many decimal places do we use with money? 2, right? Dollars and cents. And is that what we have here? It is. So $5,624.32. And that is annually. Okay? Now, I understand. This is very basic, okay? I'm just trying to make sure we know how to use the calculator. I think when I taught middle school, I would teach this in middle school sometimes. So it's probably not brand new. Is it? I don't think so. Maybe? Who knows? Okay. What's the next question asked? The next question is asking about semi-annually. What's going to change with semi-annually?
Twice a year.
Okay, if something happens semi-annually, like if there's a semi-annual sale, it's a sale that happens twice a year. So the only thing that changes is N is now 2. So I'm going to write out my formula again. A equals, still 5,000, 1 plus 0.04, except now instead of dividing by 1, I'm dividing by 2, raised to the NT, so 2 times 3. Now, depending on your calculator level of skill, it is definitely possible to just punch that into the calculator and come up with an answer right there. But there's some skill that has to be, dealt with. Okay? My recommendation is always going to be that we clean up just a smidge before we do the final answer. In that, what is 0.04 divided by 2? .04 divided by 2 is going to be 0.02. And then when you add 1 to it, we're going to have what? 1.02. So like that's what I would always start with is, okay, figure out what's inside those parentheses. Do the division and then add 1 and then raise to the power of 6. And again, if you are fancy on your calculator and you can make it work otherwise, that's fine. Just practice with me. Make sure you know what you're doing. So 5,000 times 1.02 raised to the 6. Does your answer match my answer? If so, you did something right on the calculator. Oh.
Pretty big.
Okay, what did I do?
Is it not right?
Okay, none of mine's not right.
Because I got
That's
that.
what I got.
That's what I got too.
What did I? Oh wait, no, it is right. What did I look at? I looked at something else in my answer key just now. Okay, never mind. It is right. Don't I don't know. Okay. I think I looked at the decimal wrong up there, is what threw me off. I'm not sure how, but okay, how are we gonna write this answer? 5,630 and how many cents? 81 cents. Now notice, instead of just collecting interest once a year, we did twice a year. Is my amount a little bit bigger? Did I earn a little bit more money? Not much, but some. Okay. Okay, we did annually. We did a semi-annually. Now let's talk quarterly. What if something is done quarterly?
4 times a year.
It is 4 times a year. So you're just changing out the N is 4. So 5,000 times 1 plus 0.04, and now we're dividing by 4. Raised to the NT, so that's going to be 4 times 3. And again, you don't have to clean it up first, but that's always my suggestion. 0.04 divided by 4. It's going to be 0.01. You add the 1, we're at 1.01 raised to the 12th. $5,634 and how many cents?
13.
Let's go with 13 cents because it's the 0.125 and the 5 tells the 2 to go up. Okay. You're going to talk to me if you are having calculator issues, right? Otherwise, everything's going smoothly. Okay. And the last part of this one is
12.
Monthly, which means 12.
monthly. And if something is done monthly, it is done 12 times a year. And so now my N becomes 12. Okay. So, still principal of 5,000. 1 plus, still an R value of 0.04. divided by an n value of 12 raised to the 12 times 3. I'm guessing it has to do with the boiler and we're hopefully getting more heat.
Oh, okay. I thought it was the bit too.
No, it's in the pipes in the ceiling. Okay, as I clean this one up, I know I'm at 5,000. 0.04 divided by 12 is what? This one you're going to have to use the calculator for. 0.04 divided by 12, and then add 1. What? Okay, now,
Girl.
notice, she didn't just tell me 1.003, did she? She said 3333, you know. Are those threes important?
Yes.
Yes. If you just say 1.003, you're liable to get this final answer wrong, I'm guessing. Because it's not going to be enough to keep your answer accurate, okay? Okay, raised to the 36th power.
Oh my gosh.
Okay.
That's big numbers.
Now, options of how to use the calculator here. Okay. One option is if you just did the 0.04 divided by 12 and added 1, you might have that 1.00333333 on your screen, yes? So one option that I might do is, okay, what do I have to do with the 1.00333333? I have to raise it to the 36. So one option, I would leave that on my calculator and just go ahead and say, use my exponent button. Raise it to the 36. Now I have that lovely 1.127271875 number. I'm going to leave that on my screen, and then what?
Times 5,000.
Times by 5,000.
56, 36.
$5,636 and how many cents?
36.
36 cents. Now, here's what I'm going to say. If your answer does not round to be the same as mine, your method didn't work. And I will show you another method that can work. So $5,636 and 36 cents. Okay. Your other option, well, okay, so if I had just done 5,000, 1.003 raised to the, what are we doing, 36? Notice right there. Does my answer get the same?
No.
No.
I'm not even pennies off. I'm dollars off, aren't I? With 5569.34.
It went down.
Okay. So notice that was me just doing 1.003.
36.
I cut off all those extra threes, and my answer is now wrong. Another option, though. If I do 1.003333333333, I don't know how many I just did. I just did a bunch, right? In my parentheses, raise the raise the power of 36. Notice now, do I have an accurate answer?
You put 7. That's how many you put.
Did I put 7 threes?
Yeah, that's how many threes there was on the thing.
Okay. And I just, I just did kind of a fill the screen a handful. Does that work? Yeah. I'm back at my 36 cents here, aren't I? Okay. So there's your other option. Just, if it's a repeating decimal, type in a bunch. You don't have to, go on forever, but type in a good handful and it should work. Fair enough? Okay. Questions on part A? Your first bit of homework is doing just this. Using this equation, watching for different pieces to fill in. Let's practice a little bit more on part B here. Now we're going to talk $3,000 is invested in an account that earns 3% annual interest compounded monthly. What is the value of the account after 10 years? Okay. Tell me some information. What numbers did they give me?
3,000.
3,000 is my principal. It's the amount of money we're investing or starting with. What else? Okay, R is 3%, And 3% as a decimal is 0.03. And compounded monthly. What's that tell me? N is 12. On the first part, what is the value of the account after 10 years? Then that tells me that T is 10, right? Okay, fill in your equation. So A equals P, which is 3,000, times 1 plus R divided by N, so 0.03 divided by 12, raised to the NT, raised to the 12 times 10.
That's a big number.
It is a big number, isn't it? I was thinking the same thing. So, 3,000. What about in my parentheses? 0.03 divided by 12. And then when you add 1, we're going to have 1.0025. And then raised to the 1/20th. It is a big number, but we should be making good money then on it. Right? 12 times a year over the course of 10 years.
4,000. I'm not good with big numbers. I'm about to say them. 4048.
$4,048.
Okay, $4,048 and
Like
6 cents.
6 cents. Okay. What's B change up?
100 years.
What is the value of the account after 100 years? And so now T is 100. What are we expecting about this answer?
A large.
Is this answer going to grow?
Yeah.
Yeah. Okay. You just started with $3,000 and you let it set for 10 years. Notice your balance is at $4,000. So you earned over $1,000 if you just let it set for 10 years. Let's see what happens if we can take that $3,000 and let it set for 100 years. So 3,000 times 1 plus 0.03 divided by 12. I guess that part didn't change, did it? 12 times 100. So really all that's changing is your exponent. 3,000 times 1.0025 raised to the 1,200. It is a pretty large number, isn't it?
money, 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 money.
I'm Mr. Krabs, bro.
How much money is that?
$60,000. $60,031.
What?
5 cents.
$60,031.45.
You sure what the big numbers are?
Okay, it's big numbers, isn't it?
60.
It's a lot of money.
Okay, so you got $3,000 laying around and you got 100 years left to leave that money sitting in a bank account. You can earn some major money on it.
Still won't get you by in this economy.
No, I unfortunately agree. Okay,
Even if you let it sit for a whole century.
now this would help you with like the first 4 in homework, I think, or something. We should have, but the 2-hour delay didn't allow it. So tomorrow we'll talk about another formula called continuously compounded interest. So we'll talk about when it's not how often are they compounded, but it's continuously compounding. And we'll talk about that formula, and then we'll look at how to write exponential models. Remember, if you didn't get 6.1 done yet, that's your homework to get finished for tonight, okay?
Okay.